So 210 degrees starts here, rotates all the way around. What's our reference angle with the x-axis? It's going to be 30 degrees. Okay, so opposite 30 is 1. This is 2. This is square root of 3. They're both negative because it's in the third quadrant. All right, so cosine of 210 looks like that's supposed to be negative square root of 3 over 2, adjacent over hypotenuse. So I'm going to put that in there, and we're going to simplify it. So I don't need to keep writing this again, so I'm just going to go left to right now. And by the way, this angle is 105 degrees. We're using 210 to help us figure it out, but the angle is in 105 degrees. It's in the second quadrant. Sine's positive, so I'm going to make that move right now. It's positive. Okay, 1 minus cosine 210, so 1 minus a negative square root of 3 over 2, all over 2. Okay. I'm going to stay consistent here. To eliminate this little fraction, let's just multiply by the common denominator. I only have one fraction. It's just this one, right? So I'm going to multiply the top by 2 and the bottom by 2 to get rid of that. Okay, I do have the minus the negative 2, so that's going to be plus. Nope, I'm sorry, I didn't multiply by 2. So 2 times 1 is 2. 2 times square root of 3 over 2, those 2's cross reduce, and I just get square root of 3. So we have 2 plus square root of 3 all over, and then the bottom 2 times 2 is 4. Okay, so the fraction's gone, once again, by applying that strategy of complex fractions. Multiply by it. Okay, last step is when you have square roots of fractions, we're supposed to be able to consider them separately. For example, like the square root of a over b, I'm supposed to consider a and b separately and see if I have a perfect square root. All right, so this might look a little weird because we're having a square root under a square root, but this is what you can do. Square roots of the numerator, so 2 plus the square root of 3, and then the bottom separately, square root of 4. And the reason why we're doing that is because we can take the square root of 4. It's 2. So here's the final answer. Okay, so let me review the steps. We started with 105 degrees. They said to use a half angle formula. So we want to write that as theta over 2, a half of an angle. And so we doubled it and made sure it still equals 105. It does. And now we could apply this. Sine of 210 over 2, 1 minus cosine of 210 in here. Okay, we got a decision to make always for the positive or negative, but 105 is in the second quadrant. And sine is positive in the second quadrant. Okay, so we went with positive. Eliminated the fraction, and then we broke this up. Numerator, square numerator, square denominator, and we had a perfect square root we could take at the end. Can't do anything with the top, just leave it like that. Okay? All right, it can be a little nasty the first time, but once you get comfortable with it, like most things, you're going to be fine. Let's see if you can try the cosine. The cosine is not much different. Look at it. Instead of a minus, there's just a plus. So the formula is very similar. So you go ahead and get this going and see if you can finish it. Cosine of 210 degrees over 2 equals, you got to make a decision on the sign. And it says now it's going to be 1 plus cosine of that angle. So 1 plus cosine 210 over 2. Okay, shouldn't take long since a lot of the work's there. Just small differences. Give it a shot. Okay, so here we go. Cosine 210. Now remember the big picture here. I probably should have drew this right away just so you understand. 105 degrees is here. It has a bad reference angle. All right, but the angle we're dealing with is in the second quadrant. Sine's positive, cosine's negative. So that's the difference here. All right, I know 210 can be confusing, but the formula just uses 210 that's in another quadrant to get there. But we got to focus on where that angle lies. It's here. All right, so cosine's negative. And then a lot of the math is the same, of course. Multiply by 2, we get this. Instead of positive, it's negative. Now I can take the square root of top and bottom. So here's the final answer for this one. Negative square root 2 minus the square root of 3 all over the square root of 4, which is 2. Okay, so that's what we have. All right, in the tangent one, here's the formula. Here's the exact values. We already have the sketch set up for it. Sine's negative 1/2. That's negative square root 3 over 2. Just throw them in there, and then let's simplify. Again, another complex fraction. Let's multiply the top by 2, bottom times 2. So 2 times 1 minus a negative is going to be plus. 2 times that cancels out. So I just get square root of 3. And the bottom, 2 times 1/2 is 1. So it's negative 1. They'll probably clean this up in the back. Since we're just dividing by negative 1, they're probably going to write it like this, right? Negative 2 minus the square root of 3. That's the answer. Okay, let's talk about these problems I'm going to assign you. I'm only going to assign 3 because every one of them has 3 problems to it. So it's 9 total problems. Again, don't fall behind. We got a quiz coming up next week over these 2 sections. So 21. No surprises there. 24, though, gives you a secant. So right away, I would write down cosine of u is negative 1/2. And that'll help you set it up, and then make sure you put it in the right quadrant. Looks like this one's talking about the 3rd quadrant. All right, and then the last one I'm going to assign, which is 35. Again, it's giving you 75 degrees. Don't write it as a sum like we did before. We're going to use half angles. So we're going to write this as 150 over 2. Okay, 150 over 2 is the way that now we can use the half angle formulas for 35. Okay, all right, and those are the 3. And like I said, it's actually 9 problems because they all kind of have 3 parts to it. Let's get that done by Monday.